All right. Good morning, everyone. So obviously, as you guys know, I'm not here today, but at least in the interest of time and making sure that we don't fall behind, and being very motivated and supportive today, I figured I would make a video for you just as a quick intro to the new thing that we're going to start. And as you can see, it's very similar to confidence intervals. We're still looking to try and show evidence of something, but now there's a slightly different way to do it. And it's called hypothesis testing. So for those of you who are in psych, some of these terms are going to reappear and it's going to make sense. And for those of you who aren't, it's not a big deal. We're going to start from the beginning as if everybody knows nothing. So without much further ado, let's jump right into it. Right. So with our intro to hypothesis testing, which is what this is called, right? Our new unit is hypothesis testing. We have a couple of vocabulary words that are going to be really, really important to understand. The first of those vocabulary words is the null hypothesis. This, with some notation, will look like H with a subscript of 0. So for those of you who have taken physics or are currently in physics, right, like that subscript of 0 means initial, like V sub 0 means initial velocity, or H sub 0 means initial height. Same idea here with initial, because the null hypothesis is our initial belief. So in any problem, the null hypothesis is your initial belief or the initial claim made by some organization or some person. And you'll see when we go through some problems exactly what that looks like, because it's stated for you right in the problem. The important thing is that this is always written as an equals statement. So what I mean by that, if I give you some examples here, you will see the null hypothesis. You'll have a colon, and then it'll say something like P equals 0.5. Or you might see null hypothesis and mu equals 7. So notice, those are always written as equal to statements. It's always the stated claim that this population parameter, also notice that, is equal to this number. Right, so that's one extra thing I'll write for you here. It's always about some population parameter. Always, always, always. So the next thing, right, after our null hypothesis is our alternative hypothesis. And the notation for this is H with a subscript of a capital A, which I think makes sense for alternative, right? Now, the important thing about your alternative hypothesis is that this is what you're trying to show. So, for example, let's say that there's a national organization that claims that 80% of people pass their driver's test on the first attempt. You think that true proportion is actually lower than that. Your alternative hypothesis would be that the true proportion is less than that number. So the important thing here also is that we have 3 cases, and it's always written as an inequality statement. So let's take the example that we had before of the null hypothesis of P equals 0.5. Right, let's take that example for a moment. Right, from that, I have 3 possible alternative hypotheses. Right, so from here, we can have an alternative that's P is greater than 0.5. We can have an alternative that P is less than 0.5. And the last case, we can have the alternative that P does not equal 0.5. So notice the not equal to, we'll talk about wording to look for in problems for that. But otherwise, we have three separate cases. And again, it will come straight out of the problem what you're looking for. It will say that you think the true proportion is more than, or you think the true proportion is less than, right? So this stuff will be very, very obvious from the problem. Now, another vocabulary word that's going to be very, very important is called our significance level, which notation-wise, we use a lowercase alpha, right? You actually just saw this on your confidence interval test, and I had to explain to you a little bit about what that meant. So here, hopefully it will start to make some more sense. Really what this is, we switch to the eraser, is a percentile cutoff to show evidence. Now, what do I mean by that? I mean, if we say, for example, if alpha equals 0.05, whoa, not 0.5, 0.05, that means, in plain English, my sample needs to be in the top 5% or bottom 5%, right, connected back to your alternative hypothesis, depending on which side you're testing, for me to say that there is evidence. So, and again, this is all on the assumption that your null hypothesis is true, but we'll get to that in a moment. The last thing, and this is a term that those of you in psych have heard, is a p-value. Now, very simple notation here, and this is where things can get kind of funky, and we'll talk about your calculator and how that works, right? We say, this is just p. So we have to be very specific when we're talking about our p-value versus p, the population proportion, the parameter from our null hypothesis, right? What this thing is the likelihood of getting our sample value assuming that your null hypothesis is true. So, again, everything in hypothesis testing now goes on this basis of whatever our initial claim is. That's something that we didn't have in confidence intervals, but we have now. So here is the basic idea of hypothesis testing, right? The basic idea of hypothesis testing is very simple. We have the distribution, pretend that this is a good picture, of our null hypothesis, right? So let's say, for the sake of this, this is p equals 0.5. So right in the middle here, I have 0.5 as my null hypothesis. What I'm going to do is I'm going to take a sample and I'm going to figure out where it falls. So maybe I take a sample here, and this is my sample, hence the p hat. And if that sample falls into my top 5 or bottom 5%, I'm going to say that I have evidence that my null hypothesis is false, right? So essentially, if p hat falls into our significance region, which is also called a rejection region, which, being totally honest, doesn't sound very supportive, but hey, that's okay, right? Then we can conclude that, this keeps switching to the eraser, we have evidence of our alternative hypothesis. So that is the idea. If that sample proportion or sample mean falls into that rejection region, we say that we have evidence that our initial claim was not true. Now think about, I'll bring this up, the multiple choice question from your review packet on confidence intervals, where the answer was, if the true population mean is 950, then getting a sample mean of 978 was not very likely. That's exactly what we're looking for here. We're looking for, is our initial claim correct? And if it's not, that means that my sample should be really far away from that initial assumption. So we'll talk about that more, but first we have a new acronym. Very, very important acronym, which is HAT North Carolina. Or how about them Nebraska Cornhuskers? Most people go with HAT North Carolina. And I think you can probably figure out what these are. The H here stands for hypotheses. The A stands for assumptions, which is basically the same as in panic. And I say basically because we'll talk about the slight differences. The T stands for test, hence hypothesis test. The N stands for numbers, and the C stands for conclusion still. So you can see there's a lot of similarities to panic. We just have to switch up a couple of things now to be specific to hypothesis testing, right? Instead of a parameter, we have hypotheses. Instead of an interval, we have a test. So very similar, just some slight modifications. And so to help this all make sense, let's go through an example and talk through it. So this example here, a drug manufacturer claims that fewer than 10% of patients who take its new drug for treating Alzheimer's will experience nausea. Notice, key thing here, fewer than 10% immediately gives away my alternative. Right? Fewer than tells me this is going to be a less than case. Right? In a random sample of 250 patients, 23 experienced nausea. Perform a significance test. Significance test is the same as a hypothesis test. At the 5% significance level, this now tells me my alpha. This, like we said, told me my alternative hypothesis, and also tells me my null at the same time. So, let's start. For H, I know my null hypothesis is going to be that P equals 0.1, and my alternative is that P is less than 0.1 because of the fewer than wording. It is still important here to define your parameter, where P is the true proportion of patients who experience nausea. Now, obviously, if we wanted to be super specific to the problem, it would be the true proportion of patients who take this new drug for treating Alzheimer's disease from this manufacturer who experience nausea, but I'm not going to expect you to write all of that craziness out. If it was the AP exam, totally different story. So, H, done. A for my assumptions. I still need a random sample, which I can quote the problem here, right, where it says in a random sample of 250. That's a capital I. Now, here is where things change slightly. For my large enough for CLT, we are used to, in confidence intervals, using the numbers from the problem. So like in this one, it says that 23 people experienced nausea, right? Well, guess what? It's going to be slightly different now because we have to go on the basis of the null hypothesis. So instead of just being able to use the number, I have to use my null hypothesis value, which is that p sub 0. So in this case, I would have to do 250 times 0.1 greater than or equal to 10, which it is, and then 250 times 0.9 greater than or equal to 10, which it is. But people can get caught up at this step and make a really silly mistake and say 23 and 227 instead of using the 0.1 and the 0.9. So big difference here is we have to use the null hypothesis value. Big key, biggest difference between hypothesis testing and confidence intervals. So I now get to my test. This is a one proportion z-test. We will go over how to do this on your calculator, but you're going to see it if you go into the stat and tests menu. You'll see it there, right? To show you the formula, it's z equals p hat minus p sub 0 over the square root of p0 times 1 minus p0 over n. Again, notice that we are on the distribution of the null hypothesis. That's why what we're dividing by isn't my sample standard deviation, but the standard deviation of my null hypothesis, right? So in this case, right, my sample proportion here was what? 23 out of 250. So this would be whatever that is. If I do that very quick math here, 23 over 250. Oh my goodness. Is 0.092 minus my null hypothesis, which is 0.10, over the square root of 0.1 times 0.9 over 250, right? And if I do some quick math here, if I type the right thing in, there we go. Found one. Here's what we get. We get a z statistic of negative 0.422. And what we get here is well, yeah. So as far as the test goes, this is all you need, right? When we get to the numbers, this is the important thing. So I'm going to list the test statistic again, negative 0.422, which gives you a p-value of 0.337, and I'm going to list my significance level, which was 0.05. Right, that came from the beginning of the problem where it's at a 5% significance level, right? That is where that comes from. So what I'm looking for in this problem as I come to my conclusion here is if I had evidence, then this p-value should be less than my significance level. What this is saying, right, based on the direction of my alternative, is I wanted to be in the bottom 5%, right? Because we were testing less than. What really happened was I was in essentially the bottom 34%. So my sample wasn't far enough away to show that I have evidence that the true proportion is less than 10%. I mean, even thinking logically, we're trying to claim less than 10%, but the sample proportion was 9.2%. Those are very close together. So your conclusion is always going to look the same. It's just a matter of changing some wording around. The first thing we do is we make a statement about our p-value in connection to our alpha level. So as p equals 0.337 is greater than alpha equals 0.05, here's some incredibly important wording. We do not reject. We never accept the null hypothesis. We just don't reject it. So we do not reject our null hypothesis. That's it, right? That's the beginning sentence. And then we just make a claim about whether or not we have evidence based on that. So since we didn't reject, we say there is not sufficient evidence to suggest that, and now we insert our parameter, just like confidence intervals. The true proportion of patients who experience nausea is less than 10%. So again, notice here, this is a statement about my alternative. Now, do I expect this to make perfect sense after one 15-minute video? Absolutely not. We will talk about this way more after your February break. I left some practice for you with an answer key. Do your best on it. If it doesn't make any sense, it is not the end of the world. All right, I hope you guys have a wonderful February break, and I will see you when we get back. Bye, guys.